All right, we are starting Trig Unit 4, Day 1. This unit is about graphing trig functions. In the pre-day, we looked at the key characteristics of the basic or parent sine and cosine functions. And today we're going to actually modify those a bit by changing the amplitude and doing some vertical shifts. So standard cosine graphs, we saw this in our pre-day graphs. They look like this, so sine looks kind of like a sideways S. And this is two cycles going from negative 2 pi to positive 2 pi. Cosine looks like this. Actually, let's change the color. So it kind of looks like a fancy U or V. And again, two cycles, negative 2 pi to positive 2 pi. And you can see this part is just a repeat of this second part, and likewise this part is just a repeat of the other part. So it's two cycles. Yesterday we found these things, and today we're going to look at reflections and flips over the y or the x-axis. We can have them over the x and y-axis. We're only looking at x today. But these are not flipped. They have no vertical shifts. Their amplitude is 1 essentially. So you'll see in a minute that the number in front of the function is the amplitude. If there isn't a number, then the amplitude is 1. So standard sine and cosine graphs have equations that look like this, and this is the simplest form that we're going to be looking at, because actually it's going to get more complex. We're going to be adding in letters B and C, so if you're wondering why there's an A and a D, we do have B and C. We'll get to those later. So y equals A sine x plus D, or y equals A cosine x plus D. What are the A and D? Where A is your amplitude. So any number in front of your sine or cosine is your amplitude change, and D is a vertical shift. So any number added or subtracted from this base function is a vertical shift. So amplitude is calculated if you don't have the A in front, you just had the graph. You can calculate it by the equation 1/2 max minus min. This is your maximum y coordinate and your minimum y coordinate. And amplitude and vertical shift only affect y coordinates in the trig function graphs. That makes them the easiest type of changes to graph. And we're going to do all our graphs by using our 9 hash marks from our pre-day. So we're going to convert those and then graph based on those coordinate pairs. So what does a flip look like? Well, in the equation it looks like a negative in the very front of the equation. So it's going to be a negative in front of the A, or if A is 1, it's just going to be right in front of the sine or the cosine. So here are the graphs that we drew from our pre-day. Just basic paired function y equals sine x, y equals cosine x. If we put a negative in front of them, you'll see, and these actually, the window sizes were different, so the amplitude should be the same. It's just not. So the actual change that occurred is this. You can see here we go up and then down. Here we go down and then up. For cosine, the parent function goes down, up. In the flipped, it goes up, down. And you can kind of see how those are flipped over the x-axis. So negative in front flips over the x-axis. And we'll find out later how you flip over the y. So our first graph or function that we're going to graph is 3 sine x plus 1. So we want to identify the things that have changed. Well, the A in this case is 3 and the D is 1. A being 3 means we have an amplitude change by a factor of 3. That means if the amplitude is 3, we have a vertical stretch of 3. D is 1. That means we have a vertical, it's actually positive 1 or plus 1. So that means we shift up 1. So we're going to identify the changes, and then we're going to figure out how to convert our 9 hash marks. So we're going to have a list of those hash marks. And here I have a table, original hash marks, how we convert them and what the new ones look like. We're going to take the original. As I said, our x-coordinate doesn't change today, which is nice. That's our angles, and it gets a little complicated changing those. We're going to multiply our old y coordinate by 3, which is our amplitude change, and then add our vertical shift, which is a +1 in this case. So here's our first one, negative 2 pi 0 for sine. So we're going to take our sine hash marks. This stays the same. We're going to multiply the y by 3 and then add 1. So 3 times 0 is 0 plus 1 gives us a new y coordinate of 1. So x coordinate stays the same, y coordinate multiply by 3, add 1. 3 plus 1 is 4. 3 times 0 plus 1 is 1. 3 times negative 1 is negative 3 plus 1 is negative 2. 3 times 0 is 0 plus 1. 3 times 1 plus 1 is 4. 3 times 0 plus 1 is 1. 3 times negative 1 is negative 3 plus 1 is negative 2. And then lastly, 3 times 0 plus 1 is 1. So these are our new hash marks, and these are what we're going to take to create our graph. So here's our hash marks, and what you'll notice is that we have 1, 2, 3, 4 on one side of the origin and 4 on the other. So I make 4 evenly spaced out, and if you have graph paper it makes it better. 4 evenly spaced out marks on either side of my origin, and these are my negative 2 pi. These are my angles. And today they're going to be the same angles as we had for our pre-day, pi over 2. And you can see that they're in between is 90 degrees or pi over 2 degrees. Pi, 3 pi over 2, and 2 pi. And then I'm going to look. I go from a negative 2 to a positive 4. 1, 2, 3, 4. And I just graph those coordinate pairs. So I have negative 2 pi, negative 1, kind of puts it right there. This is 4, negative pi, whoops, this should be negative here. Negative pi 1, negative pi over 2, negative 2, 0, 1, pi over 2, 4, pi 1, 3 pi, negative 2, and then 2 pi 1. Once you have those, connect your dots, and you should have something that looks a lot like the graph we created the other day. It's going to be 2 full cycles, and that's what I expect of your graph. So for each problem I expect to see your hash marks, all 9 of them, a well-marked graph with your scales. So I assume this is 1 unless you tell me it's different. And then we need to, for each question on your homework, you're going to have to identify key characteristics. Y-intercept, so where is x0? In this case, it's been identified as one of our hash marks, so it's 0, 1. I'm going to get to x-int in a minute. Minimum is which coordinates have the minimum y. So this is a minimum y value. Our minimum y occurs at negative 2. So you're going to give me the 2 coordinate pairs with our minimum, which is going to be negative pi over 2, negative 2, and 3 pi over 2, negative 2. Please give them to me as ordered pairs. Same with max. What's our max value? It's at 4, and we've got 2 sets of ordered pairs with a max value of 4, and those are negative 3 pi 4 and pi over 2 4. Again, ordered pairs should be given. Amplitude, I said, is 3. Vertical stretch is just our amplitude in this case. Flip, we don't have any negatives, so there's none, and it has a vertical shift up 1. So those are the things, the characteristics you're going to have to put down today. Last one is x-int. If our hash marks sometimes have our x-intercepts, if we have any hash marks that have 0 for y, that's going to be an x-intercept. We don't in this case. So you're going to, on a graphing calculator, plot 3 sine x plus 1, and again do it in radians. So your x min is going to be negative 2 pi in radian mode. X max is going to be 2 pi. Your x scale is going to be pi over 2 for now, and then your y min, you have to look at your new y values. In this case, I would make it probably, I'd make it a little less than your minimum, so I might make it a -4. Y max a little bigger than your max, so I would maybe make it 6, and your Y scale probably 0.5. Graph it and then do a trace, and you're going to find the coordinates of your, in this case you've got 4 x-intercepts, and this is about -3, 0. This one is about -0.3. This is about 3.3, and the other one is approximately 5.9 or 6. It's going to be approximate. I give you a lot of leeway on that. And that would be one complete answer to one of your homework questions. So they take a bit of work, which is why you only have 6 problems. All right, next example. -3 cosine x plus 2. So let's identify what we have. We have an amplitude of 3 again, which is a vertical stretch of 3. We have a vertical shift up. This should actually be 2. I hope I did the right conversion. Yes, I actually did. And then we have a negative sign, which causes a flip over the x-axis. So this is similar to the last one, but we have to deal with this. I'm going to show you how you do that. So again, we convert our hash marks. Whoops, and this should not be negative. This should be positive x. Our x coordinate stays the same. We're going to multiply our y coordinate by a -3. So we're going to add the negative to the amplitude, multiply our y coordinate, and then add our vertical shift. So start with your cosine hash marks. In this case, we start with -2 pi 1. I'm going to multiply 1 by -3, which is a -3 times 1 is -3, plus 2 is -1. -3 times 0 is 0, plus 2. -3 times -1 is +3, plus 2 gives me 5, and so on. We're going to get our new set of hash marks. And again, once you have those, you want to graph them. So here's my xy graph. 1, 2, 3, 4, 1, 2, 3, 4, -2 pi, -3 pi over 2, -pi over 2. And then likewise. And what are my y values? Well, I go from a -1 to a 5. So 1, 2, 3, 4, 5, -1. And then I just plot my ordered pair. -2 pi, -1, -3 pi over 2, 2, pi, 5, pi over 2, 2. This is -1, 2, 5, 2, -1. And again, if you've done it correctly, it will look a lot like the cosine graph, except you can see this time it is flipped, and it has amplitude and vertical shift changes. All right, and then we're going to find the same things as before. Y-int, well, we have it right here. Y-intercept is at 0, -1. X-int, again, I had to use my graphing calculator, and we're going to have 4 of them, here, 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 and here, and this is where I found them approximately. Minimum values are when y is -1. I have 3 minimums. Max is when y is 5. Amplitude 3, vertical stretch, vertical shift, and I would like you to say either say +2 or up to, so I know that you understand the direction. And then we do have a flip over the x-axis. Okay, so I want you to find the new hash marks for 4 sine x minus 1, and you can check them in class and bring any questions to class.